How many beads do you think are on this chain? Well, we could count every single bead, but that would definitely take too long. We could count how many 7 bars we have and add those up, but there's also got to be a faster way. We could count how many times we have 7, and we could multiply 7 by how many times we have it. But let's try something even faster. Here is the chain we used before, and this was 7 times 7. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 times. Let's see how many 7 times 7s are in this chain. So how many times do we have 7 times 7? We have 7 times 7 one time. We have 7 times 7 2 times. 7 times 7 3 times. 7 times 7 4 times. 7 times 7 5 times. 7 times 7 6 times. And 7 times 7 7 times. So we have 7 times 7 7 times. Knowing what you've learned about exponents, how could we write this, which is currently in expanded form, how could we write this in exponential form? Well, we find the factor that's being repeated. In this case, it's 7, so we'd use 7 as our base. And then we count how many times it's being multiplied by itself. 1, 2, 3. So we would use 3 as our exponent, and it would look like this. So the way you say this is 7 to the 3rd power, or 7 raised to the 3rd power, or 7 to the 3rd. Just like a number raised to the 2nd power has a special name, which is that number squared, any number raised to the 3rd power is being cubed. So this can also be 7 cubed. Now, why would we call 7 times 7 times 7 7 cubed? Let's look at our concrete physical form of 7 cubed here and see what happens. Well, we know that 7 times 7 can be folded to look like a square. And this 7 times 7 would be another square. And this 7 times 7 would be another square. Our 4th 7 times 7 would be a 4th square. Our 5th 7 times 7 would be a 5th square. Our 6th 7 times 7 would be a 6th square. And our 7th 7 times 7 would be a 7th square. So what if we put those together here? Let's see what that looks like. Okay. So does this kind of look like something? A cube. The same number of beads that are here are also in here. This has just been bound together in such a way that we can clearly see it is a cube. So what makes something a cube? Well, it has the same size length as it does width, which is the same as its height. So let's check it on this cube to make sure this is an exact cube. 1, 2, 3, 4, 5, 6, 7 for the length. 1, 2, 3, 4, 5, 6, 7 for the width. And 1, 2, 3, 4, 5, 6, 7 for the height. So this is an actual cube. So when we write any number cubed, in this case 7 cubed, what we're saying is take the base of 7 and use it as a side to make a cube. And the number of beads that would be inside equals 7 cubed. Why don't you give it a try? 8 cubed. Here's the exponential form. You write it in expanded form? Okay, it would be 8 times 8 times 8. So 8 is the factor that's being repeated, so that we use for the base. And then how many times is it being repeated? 3, so that's the exponent. Okay, let's try another one. Here you have 13 times 13 times 13. That's the expanded form. How would we put that in exponential form? We would put 13 cubed. So the number that's repeating, you write that as the base, and then you count how many times it's repeating, and you write that as the exponent.